All right, we're going to do section 9.3, and we're going to sketch graphs of quadratic functions with a few important points. The first point to find is the y-intercept. Basically, if you make x equal to 0, you can solve for y. So negative 3 times 0 squared plus 6 times 0 minus 7 is negative 7. So our first fun point to plot is 0, negative 7. Second point, different problem, is the x-intercepts. So to find your x-intercepts, you're plugging 0 in for y and solving for x. So I want to know what makes each parentheses equal to 0. So this would be 1. So 1 gives 0. So 1 gives 0. And this one would be 4. So 4 gives 0. The next problem is the line of symmetry. Now, if you want to define the line of symmetry here, it would be directly between 1 and 4, which would be at 2.5. And this is factorable. You would plug 2.5 in for x and then solve for y. But this one is not factorable. There's no two numbers that multiply to give you 21 that add to give you 6. So we're going to use a new thing. Here's your new topic. Standard form is written ax squared plus bx plus c. A is the coefficient of x squared. So in this case, a is negative 3. B is the coefficient of x here. So b in our case is 6. And we don't need our c right now, but c is negative 7. And to find that middle point, you can do this special little negative b over 2a, which is part of the quadratic formula, which we'll be working with in a few more days. So I'm going to explain where this comes from then. So we have negative 6 over 2 times negative 3. So that's negative 6 over negative 6, which is 1. So to find the actual vertex, we're going to plug 1 in and solve. So negative 3 times 1 squared plus 6 times 1 minus 7. That'd be negative 3 plus 6 minus 7, which is negative 4. So the line of symmetry here is 1, negative 4. So if we want to sketch a graph of this, our y-intercept, again, you're going to plug 0 in for x and solve for y. If 0 is in for x, that means that you have 0 squared minus 4 times 0 minus 5. Our x-intercepts are in factored form. This can factor into x minus 5, x plus 1. Our x-intercepts are one that's equal to 0. So our two x-intercepts are at 5 and at negative 1. So our ordered pair point is 5, 0 and negative 1, 0. And then our line of symmetry is directly in between those two. Or you could do negative b over 2a. If we did negative b over 2a, you would get 4 over 1 times 2. You would get 4 over 2 times 1, which is 2. And then we're going to plug 2 in. So 2 squared minus 4 times 2 minus 5 is 4 minus 8 minus 5, which is 9. So our vertex is the point 2, negative 9. To plot those special points, we've got 0, negative 5. 5 gives 0, and negative 1 gives 0. And then our line of symmetry, where everything is symmetrical, is at 2, which is making good sense, negative 9. So that tells us that we have this other lovely symmetrical point right here if you want to add that in. And then you can draw your parabola. In the next problem, we are going to factor this the long way. So, well, we can do the y-intercept first. If you plug 0 in, you get negative 12. And then the factoring, the two numbers that multiply to give you negative 24, x squared, and add to give you, let me make my diamond, I'll make it right here. And add to give you negative 5x is negative 8 and positive 3. So if you make your box, and you've got x squared, 2x squared, and negative 12, and 8x, that's a negative, and 3x, that's a positive, you're going to have your 2x and your x, and then your negative 12, this is going to have to be 3, because that's 3, and this will have to be negative 4. So your factored form is x minus 4 and 2x plus 3. So your 2x intercepts, you want to know when 0 equals x minus 4. And then you also want to know when 0 equals 2x plus 3. So the first solution is 4. That means your ordered pair 4, 0 is one of your x-intercepts. And your second one, you would have to subtract 3 and then divide by 2. So your second ordered pair would be negative 3/2, 0. The line of symmetry is directly in between those, or you can do the negative b over 2a. Again, a would be 2, and b would be negative 5. So that'd be a positive 5 over 2 times 2. So our line of symmetry is 5/4, or 1 and 1/4. Line of symmetry. And then the vertex, you plug that in. And so we're definitely going to need a calculator for this. 2 times 5/4 squared minus 5 times 5/4 minus 12. So in your calculator, you get 3.125 minus 6.25 minus 12. And that is negative 15.125. So our vertex point is negative 1 and 1, positive 1 and 1/4, and negative 15 and 0.125. So if you plot your main points for this, you get your y-intercept, which is 0, negative 12. And we might as well count by 2's. And then 4, 0. and -1.5, 0. Your line of symmetry is at 1 1/4. So just on the other side of this. And it's down here at -15.125, so right about here. So this parabolic curve is going to look like that. For our last problem, we're going to sketch a graph of the height of the football in relation to time. So we might want to title this football kick. And our x value is going to be time, and our y value is going to be height. And the equation again is -16x squared plus 64x. We could take a -16x out, and we would be left with x minus 4. That might be a nice place to start. So we know that our y-intercept is 0, because when you plug 0 in, there is nothing right there. We know that our two x-intercepts are 0 and 4. All right, so now we're going to find the vertex, which is -b/2a. So that is -64 over 2 times -16. So the line of symmetry is 2. If you plug 2 in, -16 times 2 minus 4, that is -32 times -2. Or if we made a little table here of our most important points, 2 would give positive 64, 0 would give 0, and 4 would give 0, and then 1 would give us that 48, and the matchup of 3 would give us 48. So maybe we could go up. We only need to go up to 4, so we'll skip maybe 4 in between. You want to spread the graph out as much as possible. And the label of that axis is the height in feet of a football kicked compared to time. So since we have to get up to 64, we could go by 4s or 5s. And a good title would be a football kick. So our points plotted are 0, 0, and 4, 0, 1, 48, and 3, 48. And then 2, 64 is our vertex. This is our parabolic curve. This is the data that makes sense. The other data should be excluded from a domain. And if you look at the line of symmetry and fold these on top of each other, they should be a perfect mirror image. My graph could probably be a little bit better, but hey, you do your best every day. Have a good evening.